Okay friends, we looked at what STL is and an introduction to the first sequence container called vector in the previous module. In this particular module, we will be looking at a few more containers and a few generic algorithms. Here is the list, the second container that we are going to see. Remember what we discussed about list is basically a representation of a doubly linked list. I do not need to define a doubly linked list in my program any longer. I just use list and do the job. I just say whatever list I define, I just dot insert will insert an element. I just find a place to insert and then insert it that place. So, that is how it is done. In fact, you can even delete and all that. So, but at random places in the sequence, that is the power. Begin and end returns here the earlier case vector begin and end return something called random access iterators. So, sort can be used with vector. Here begin and end returns something called bidirectional iterators, which is of lower order than the random access iterators. So, you can't use sort here, okay, but then you can use find, because the find demands only something called input iterators, which is a lower requirement than even the bidirectional iterator. So, this is very clever design. Okay. So, you have some order of iterators which the algorithms demand, and algorithms are happy if you provide him the same iterator or any lower level iterator, algorithm can work, but other one, the higher one, algorithms cannot work. Okay. So, let us talk about the cricketer class needs overloaded operator, for example, here in this case. Okay. So, if a class does not want itself to be used in list, it does not overload double equal to. So, if somebody wants to insert that object in the class, you do not, and that is the power you have with the objects, and that is the generality that you have with the objects. It is a very clever design, as I say, it is extremely clever design. Now, let us try to see how it works. Okay. If you have, as I said, if you have studied how you did something like this in the previous module, okay, something like this. Now, what I am doing it list cricketer ls, simple, okay. And the same thing I am defining all the cricketer elements, and now I am pushing them, done. And you can see that this syntax is all same as vectors. So, if you studied how one container works, is you do not need to worry much about other containers, it is that simple. Okay. And again you can see that the way you define iterator is also the same. Okay. Now, the power here, I define one more cricketer element called Shikha Pandey, and now what I do is I find this thing. Now, find is again a generic algorithm. It demands three things: the beginning of the range, the end of the range, end plus 1 of the range, and the object that you are interested in finding. Okay. So, find returns an iterator of the same time it is passed to. So, in this case it is list. So, it is a bidirectional iterator. So, that bidirectional iterator is returned here in C index. I do not need to specify the type here, it can actually be the type depending on the container that you are using. For example, when you define list, C index will always be bidirectional. Okay. So, this iterator is assigned here. At that point of time, what I do is I insert Shikha, the cricketer that I have just defined. So, it is an additional element that is inserted, and now I display all of them. I start with ls dot begin, I will go till ls dot end, and I will just increment that, a simple addressing mechanism which we have demonstrated in the previous module. Okay. So, here I am displaying that using dereferencing the pointer itself. Okay. And you can see the output and see the additional value inserted. Shikha Pandey is added here. We wanted, so what we did, say that we find Dipti, and once we find Dipti, at the same place we insert Shikha. Okay. So, it is like Mitali pointing to Shushma, is pointing to Herman, which was pointing to Dipti and Zulan, okay, this way. Now, we find this place Dipti, okay, or find, and say that Shikha is to be inserted. So, what actually is done, now this pointer is pointing to Shikha, Shikha will point here and this Herman will point to this place. Now, this all is basically a pointer adjustment. I am not moving an element around, it is only pointers because it is doubly linked implementation, and that is the reason why insertion and deletion in this particular container is of constant time O(n). Okay. And that is, this is the only container where you get O(n) as an insertion time. Okay. Okay, it has to only reshuffle pointers, as I said. Vector needs to relocate elements. So, now that is also very critical for all of us to understand. Let me take an example. Suppose if I have this vector and I have some values inserted 1, 7, 9, 14, 17 already. Now, suppose if I insert 3, now I can't insert 3 here, and it is to be inserted at the second position. Okay. Suppose if I decide that I will insert at this position, I can't do it unless and until I move these elements down. So, I will have to extend the vector, and if the vector is already of the fullest size, it might even be relocated. Okay. So, I will move 17 here, then 14 here, then 9 here, then 7 here, and then at this point of time I have this place empty. So, I can insert 3 here. Okay. So, that relocation is to be done, I need to do it. Okay. And bigger the vector will take more the time. So, insertion is not a constant time operation on vector, unlike list. Okay. So, accessing a random element is easy in vector, unlike list. If I want to go to any element, nth element, I can jump there directly, but list cannot do it. So, two things are different. List is used for some purpose, vector is used for the other purpose. Vectors automatically grow, as I said, but they at that point of time when the vector doubles itself, many a times you need to relocate, because random access is only possible because vector elements are stored in contiguous locations. Okay. So, if there is no memory ahead, what you are supposed to do is to pick up all these elements and store at some other place where you have the additional memory available to store elements in a contiguous fashion. So, it might demand relocation, and that relocation and copying elements will take a while. Okay. So, that is the issue. Okay. As I have mentioned, both C++, both this thing list and vector offers different advantage, and it is your choice. And C++, as I said, the best thing about C++ that is offers you a choice. You need something, you use that. Okay. All options are available to you. You have to have that fine judgment to use what you want. Okay. Now, the other container is called DQ, as I said, is a double ended queue. You can insert from one end, insert from the other end, delete from one end, delete from the other end, allowed. Okay. It is quite similar to other sequence containers, except for this difference. It additionally allows, remember it earlier we talked about something called push back and insert at the end. Okay. List allows push front, vector does not allow push front, vector only allows push back. DQ allows both push front as well as push back. So, you can insert here, you can insert at the other end. Okay. And what you need is operator double equal to. But DQ can provide, DQ actually works on random access iterators. So, double equal to is fine, accepted. Okay. So, that is going to work here, we do not need to worry about, because I am only going to use find. If I am going to use sort, I need to overload that less than operator. Okay. So, DQ can use both. Okay. Now, let us look at this. I am defining DQ. Now, you can see that again the definition is quite similar to the vector as well as list. Name DQ, class cricketer DS, cricketer Mithali, and I am defining all those cricketers like the earlier case, and I am also pushing them like done before, but I use push front rather than push back. So, Mithali is inserted, and then on top of it I am inserting Veda and others. Okay. So, I am not inserting at the end. So, I am getting the order reversed, and what I am doing is I am defining an iterator now and I call it cricketer index, and then I iterate through that using the very iterator is the same logic which I have shown you before, and it is not shown, but the output is exactly in the inverse order. Okay. So, that was DQ. Now, let us look at sorted associative containers. Let me remind you what sorted associative containers are. They are containers where the information is inserted in the exact order. Okay. We do not need to specify the order ourselves. Remember, the order is decided by the content itself, the contained object itself. In the earlier cases, our contained object is the cricketer, and we have something called jersey number in the cricketer class, and we have defined our operator less than operator, which is very important for sorted container. You can't insert an object in sorted associative container unless you define operator less than constant as constant. You will have to define that thing as constant. So, operator less than constant has to be defined for every object that you use with sorted associative container, obviously, because you need to compare the elements with other elements to find the exact position. Okay. So, that is the reason why that is demanded, and that the object or the class decides its own order itself. Nobody else is going to do that for it. But then when you define a class, you have to have that operator overloaded, and that is very critical, and this is very important for you to understand. Otherwise, the syntax of using all these containers and algorithm is pretty simple. Okay. If you have come so far, I do not think you will have much time learning about all this. It is very simple. The only issue is this. Okay. When what will not work? For example, if you use a class where operator less than is not possible, you have not overloaded that operator, and then try to use an algorithm which demands that, or try to use a container which demands that, and you get errors, you must know why you are getting those errors. Okay. In most cases, actually, when in fact I am working using Xcode on my Apple machine, whenever I make a mistake of that type, it jumps me to some code of the library, and it is pretty confusing at the first shot, why I am jumped to this place, but then if you read that message, you realize that this is the case, and that is the reason why I am stressing that here. So, you might forget to overload equal, double equal to, or less than, and sometimes you define wrong operator. For example, if you are dealing with list, inserting a cricketer element in the list demands cricketer object has double equal to operator overloaded, not less than. Okay, because it returns bidirectional operator, bidirectional iterators which demand that thing. So, if you have not done that, you might get an error. Okay. So, when you are getting such an error, doubt this thing, that the contained object, check if the required operator is overloaded or not, and if it is not, do it. Okay. But then the advantage is that okay, when you use the sorted associative container, as I said, it keeps the data in the sorted order. When you insert it, it finds the right place and insert itself. It will take a while to do that, but then the reference is much faster. As I said, it is O log n to the base 2 speed. Reference versus insertion time is usually an issue, in which case I would prefer sorted associative container. For example, I am having all my students there in my program, and I am referring to that 100 times. So, insertion is done once, but the reference takes place 100, 200 times. I would like to optimize the other part and not the first part. So, in the case where I am using a sorted associative container, it obviously improves the performance of my program. Okay. So, binary search is applicable on height balance trees. As I said, this sorted associative containers deploy height balance trees, and that is the reason why you get the reference pretty fast. Log n to the base 2 is the time that you need. Another point is that the access using a key value, okay, this thing. Okay. For example, if you insert an element called int, you do not need to specify that order, it is automatically defined. And when you use a built-in type, you will have to specify that order. Okay. It is already available when you use a built-in type, but when you provide a user defined type, you will have to do it yourself. Okay, that is the idea, and that is, I believe, is a very good design. Okay. So, how it is done? Incoming element is compared with the existing elements and inserted as the position where the sorted order is maintained. Okay. So, for example, I have 1, 3, 7, 23, 4, 45 and 71, and if I get 12, we will find out where it should be inserted and insert at this place. Okay. And we will not look at that thing in a sequential order, we will do something else. The binary search algorithm, probably if you know a bit about binary search algorithm, you know how to do it, but if it is not, if you do not know it, please understand that it is pretty fast. Okay. As I said, this is to be defined and used. Okay. Unlike sequence containers, they can only be accessed using keys and not indices. Okay. You may use indices, not directly, but then normally this reference is this. Okay. Set only stores a key value, map stores two values, key as well as the other item, and provides O log n to the base 2 search time, that is the power of it. Map, the first sorted associative container we will look at is called map. Map contains two items, first is the key and the other one is the value that you are going to store with that key. And we are taking two different type of maps, first with a string, the other one with an object, okay, of type cricketer that we have seen before. The first one is string, as I said, float. As I said, map contain two things, first thing is called as a key and second is the value. Here is the key and this is the value. Okay. This name is S cric data and this is called C cric data. Okay. Map provides insertion in a very simple form, this string with this value. Okay. In this case, this object with this value. Okay. So, this is how it is done. So, basically I am providing Mithali as with 4000 and here this is string and here Mithali is an object, cricketer object with value 4000, and that is what map is, and I am inserting it inside. Okay. And I will be able, and please understand I am not sorting it on this value, I am sorting it on this value, and that is the key. The first item is the key, second item is the additional value. And map can provide array with arbitrary index type. Index, you can see that here the index is with string, here is the object. Now, you may say that how these strings are organized, how they are sequenced. Yes, they are, the string object contains operator less than, which has its own order, okay, chronological order, which we observe in books. This case of Mithali, the class that we have defined it in a way that the order is defined based on the jersey number. Okay. So, it is user's decision to do it. So, the information is stored in that order. Okay. If, and again remember we are talking about map, if I insert S cric data Mithali 4000 and then we say that S cric data Mithali 5000, what will happen? The 4000 record, the record with value 4000 will be overwritten by the new record. Okay. So, we will not have two values with the same key. When we use multimap, we will have. Okay. How it is used? Okay. So, we will begin with this string float, the first type of map, and this first string is assigned first value, second string is assigned second value, third string is assigned third value. I have not specified it anywhere, but it is basically number of runs scored by that player. Okay. This is the string and float map. Now, I am defining one more map here. For that I need three objects. So, I define three objects of type cricketer, Mithali, Zulan and Herman, and I am giving them two values, the jersey number and the name. Now, what I am doing is, I am doing the same thing, C cric data Mithali value 4000, Zulan value 2000, Herman value 3000. Okay. So, I am just doing it, it is inserted in the sorted order of jersey number, not these values, okay, because I have defined class as the cricketer class as to be ordered using that jersey number by specifying operator less than in that class accordingly. Okay. Now, I am using multimap, but multimap I can't use that shortened operator. Okay. There is a problem. Let me specify what the problem is. The problem is like this. Okay. I am storing information with Mithali. So, Mithali in World Cup 1 scored 5000. Mithali in World Cup 2 scored 7000 run. Now, I want to retain both, okay, and like to insert both, and that is the reason why I need multimap. But the problem is that I can't do it here. If I do something like this, equal to 5000 and then equal to 7000, later on when I am referring to this C crick data Mithali, okay, so I am referring to C crick data Mithali. Which one I am referring to? Okay, which one I am referring to is not clear. There is an ambiguity. That is the problem, and that is the reason why this shortened notation is not used. There is something else which is used here. There is an additional container called pair. Now, that pair is very simple. Pair is a collection of two different items together. I can have int 1 1. Now, this is how I am defining, or I can say pair string int Ganesh 1, something like this. So, I can use this pair. Okay. How it is done? So, pair cricketer float Mithali 4000. Okay. This is how I am going to use, and then I insert this pair inside the S crick data. Okay. So, unlike that overloaded operator, array subscription operator, I am using this. Reference is possible to be done using something called FindRemember. And now, this find is not an algorithm that we have seen before. This find is a member function to this. Okay. For example, I can say that S crick data dot find Mithali will find Mithali in the order, and then I may insert my data, okay, or I may read that thing. I do not, in fact, whenever I insert, I do not need to specify the position, is always inserted in that order. But remember this Mithali object, when I specify this map contain two elements, is not one, there are two elements. So, what I get is a collection of two elements, a pair. The first element in the pair is known as first, the second element in the pair is known as second, that is simple. So, I am using an iterator called position, which I just call this find. What I do is position pointer first, position pointer second to get both elements one after the other. Okay, let us see how it is done. So, I just define cricketer, Mithali, Julian and Herman, and then I define this multimap and I insert both of them twice. Okay. So, I am inserting both these values, okay, Mithali 4000 and so on, the same thing which we have done before. In fact, this I can use this with map too. I am not specified that thing. Normally people do not do, because that array subscript operator is very readable way of doing it. So, normally people do not do it, but if you want, you can use the same syntax there as well using pair. Okay. So, in case of S crick data insert pair, this thing I can run the same program by just changing this from multimap to map. I will work. The only issue is that when I am inserting it twice, will not insert it twice, the second version will overwrite the first one, but otherwise it is going to work. As I said, this syntax is very acceptable in case of map as well. Now, but how you can find a typical place? So, you just find typical object using find and then display the first value and the second value. Okay. So, output may be jersey number 1, name Mithali Raj, run scored 4000. So, that is how it is done. And I can actually do something like this also. For example, for position equal to S crick data that begin the first element and the end last 1 plus last element, I will just increment it one by one. So, it is not that you can't move around this one after the other, but obviously you normally do not do it and you display everything. Okay. And if you have used map, you will get single version, single copy of everything. If you do not do it, because we have already inserted it twice, if you use multimap, you get it both the times twice. Okay. Same way I can use set, but then we are using something else, and in fact, we define a vector and we insert in a vector, and now we define a set here, and you can see that defining a set only need one element. You do not need multiple elements, only one element will do. Why? Because set only get those objects in sorted order, will not have the additional value like map. So, it is a simpler version of that thing, and I just move around, but then see this, I am using an insert member function for set, and I am just inserting. So, I am just reading from the vector, displaying it on the screen, and then copy it here as well. So, I am doing the simple and then display this set. Now, remember this insertion happens always in sorted order. So, the vector, in fact, I purposefully enter values in different order than sorted order in the vector. So, when I display vector, I will get all unsorted values, but this set where the vector values are read and inserted will insert that thing in the right order, and that is the reason when I display set, I will get the sorted order. Okay. So, you can see that the vector 1, 6, 4, 2, 5, 3, that is the vector that thing, and when the set output is 1, 2, 3, 4, 5, 6. I am not explicitly sorted anything here, there is no sort statement. Please understand, every element in set inserted in exactly the same sorted order, which is specified by the contained type. Multiset, everything is the same, only thing is that you define multiset here, and here I am doing one more thing. I am using an iterator, will just vc dot begin to end, will just copy it everything here. Only the thing which you need here at this point of time is a default constructor for the cricketer class, and if you do not specify, will not work. So, additionally that is needed, but once you do that, this is done, and once you do that, fine, you can even define the iterator and do it. Almost this is the syntax is the same which we have seen before, and will only display it twice. Now, we will look at the find. Remember, we have already looked at find and know that there are 3 arguments to it. The first element in the range, last plus one element of the range, and the value that you want to search. We have already seen this search for vector. Now, this is for list, and you can see there is no difference. DQ also there is no difference. One great thing is that I can actually use this with an array, where the iterator is actually the type of pointer, okay, that I am using. So, is an integer array. So, I am defining an integer pointer. Okay. So, and I can use find with an array as well. Similarly, sort, I have defined DQ and I have copied, actually you can see that we has the begin and end, I am copying it here. So, DS is populated with these vector values, okay, and then I can call sort ds dot begin, ds dot end. I can't remember, I have used this thing with vector also, but I can't use sort with list, remember, because these two elements, sort demands them to be random access iterators. If they are not, sort will say no. So, list, if I use ls dot begin and ls dot end, will be bidirectional iterator. So, sort will throw a compilation error. Integer array also can be sorted using this. The other one is called copy. So, again its syntax is very simple, first element, last element in the range, and where to copy. Okay, this is a new vector. So, this is a vector data is copied to a vector. Now, this is again the same vector data is copied to a list, the vector data is copied to a DQ. Okay. All three cases, find, sort and copy, you need to have that include algorithm. Okay. So, if you do not include, you will get an error, but otherwise that is just fine. Okay. With that note, we conclude this particular module, module number 33. What we did in this module, we looked at a container called list, we started with that list, then we looked at DQ, We have seen how these containers work and what they demand. List demands operator double equal to, while DQ can work with double equal to or greater than less than, sorry. And then we have looked at 3 algorithms. Okay. First is find, then sort, then copy. Okay. Basically, what we have shown in these 2 modules is that how you can define STL containers and use them. STL containers, something which I have not talked about right now, and probably you will not even find that thing in my own book, but then you need to read about STL in a little more depth. But you will be able to have your own containers, as well as you will be able to provide your own algorithms. Not only that, you can change some other factors like how the memory is allocated for the vector when the vector is incremented and so on and so forth. So, you may have a case where when somebody defines a vector will have 500 elements or 1000 elements already allocated. So, it is possible you can do something of that sort. So, that kind of flexibility is also available with STL. With that note, we will conclude our discussion on STL. Thank you, friends.